bring some energy to the room to keep us pumped up. So I'm going to do that. And it's great to be back in Romania. There's a great story. This is where I learned about architecture, and I've had more and more learning today from seeing the countries in progress. So exciting. And I'm going to talk about Asheville, North Carolina. And down on the left, you can sort of see a fly-in to the East Coast here. Right in here, and on the East Coast, this is a mountainous region, so a lot of pressure zones out there. I've tried to get all of my metric units because I am that American that works in gallons and feet and million gallons. So excuse when the translation is not quite there. You think English to Romanian or the other languages is bad. We should have gotten the metric system a long time ago. Nonetheless, 40 pump stations, 55 pressure zones, quite a bit of relief out there. This particular utility, I'm excited, has followed the IWA water balance methodology and developed a program, and they have been at it for over 10 years of really leaning in on this process. These are the teams. We had several speakers talk earlier about individual teams and really having buy-in. They have teams that actually have set out and are executing their non-revenue water program. Cavanaugh, as a consultant, was brought in to assist them, really help them move forward. The presentation we just had on the technology, in this case, this particular utility, really from a size and kind of a data security, they were not in a fee-for-service type of analysis of really looking at the metering. And they really wanted to develop an advancement of their ongoing metering program that they had. So this was really to come and meet them where they were and start, as Stuart said earlier, go from step 3 to step 4, and to do it in a way that's cost effective. So they have gone through AMAR conversion, metering technology, so they do have some very comprehensive data that's available to them now. They also have, they understand that they've got some hydraulic issues out there in the network vaults, and where you can't get good testing, things that I'm sure many of you have experienced and seen out in the field. By the way, the real brains behind this is actually getting his haircut here in the corner. That's Brandon Buckner, and he can tell this story with vigor because he brings a lot of energy and pride in his work. And what we also heard throughout the course of the day was leadership and management involved. It works the other way too when you've got a staff that's actually bringing energy back that helps management keep the fuel going to engage these practices. So they have been testing meters throughout the years, and obviously the small meters have been in a testing, obviously for them to get to the AMAR conversion. They've done all small meters. But they really wanted to lean in on the large meters. They started really feeling that that's where the bang for the buck could happen. And I'm going to show a plot here in just a moment. In this, they have been long-standing, clear understanding that it's about the volume of loss, it's about the value of the loss, and it's also about the reliability of our data. How valid is our data to be to advance business practices and business decisions? So leaning in, they broke down losses through the water balance and break down apparent and real. And you can see on the volume side here, we've got our volumes. We've got the values on the right-hand side. That's good, but that really doesn't tell us everything we need to know. So they went further. They did leakage component analysis. They did component analysis of their apparent losses, their reversible losses. Just started to look at it in terms of the volume and the value again, kind of in those components. What they wanted to get to was really that metering and accuracy. Let's take a look at our meters and say, okay, how much of this is in small meters? How much of this is large? And I'll define that in just a moment. And then, we've heard about it, how much is meter misapplication? So in looking at that, they did an analysis of their meters, and this is one of those that did not get changed, but for them, a large meter is 38 millimeters. That's probably an odd size to call in European standards, but 38 millimeters was their break point, about 1.5 inches. And they said that's 1,700 meters, and out of our total that we've got there, some 60-some or 55,000 meters that's out there. But if we look at it on a volume standpoint, that's substantial. So the volume is substantial to us if we really want to lean into our large commercial meters. So then they did the next step, which to actually sort those meters by the revenue. What is that meter generating every year? And then plot those. And interesting, when you do that, this is a very simple thing that we can do as utilities. You take a look and it's like, wow, we went from 1,700 meters down to 500 and some meters, but even more importantly, look at this group of meters that has the cumulative value fairly substantial. So they've now taken that 1,700 and best practices, at least the AWWA M6 manual says, you got to test your large meters every year. Those are broad definitions. And that can be daunting for a team that has very limited staff and resources. And again, they're leaning in multiple areas, as you saw from the first slide. So this gave them at least a snapshot that, gosh, we need to even optimize this more. So when they were going out and doing testing, they wanted a robust model. Actually, and one of the speakers earlier said, where are we in the flow range? They realized that not all of these meters are at the standard breakdown of, quote, flow ranges. So they needed to do some flow logging when they were out in the field. So they said, we want a tool that every year we can import, where's our large meter population, where's the revenue, let's look at the benefit cost analysis of that investigation. So, kind of laying out the tool, they sort of looked at it from, again, the historical year one of this, and they're, I think, probably year 4 of their program. They made assumptions. Where were we in flow ranges? What is the cost that we've got, the cost of test, the cost of repair, the cost of retesting of that meter, and start to really lay out the elements of the program itself. So in looking at this, they actually, in laying out the optimization for it, they said, okay, we're going to start to do monthly testing, but we want to be guided towards those meters that we think are challenging. We want to be able to go out in the field and see, are there challenges with the setup? Are our assumptions of the flow, are they correct or not? They wanted some filters, and they also wanted to take the retest data in the field, what they actually are logging and seeing, and actually put that and update the model. And then obviously we get actionable work orders and repair and replacement. So a little bit about the data. Every year they import information in by customer, by account, by those sorted down for the largest customers from a revenue standpoint, and looking at that and laying those in there. They then are doing filters, and just to look at this, it's also taking again to show you the value here on the right-hand side, information on install dates, and then just some general information on account number, your typical identifiers that you would look at. So then there's the testing or the color coding, which is a kind of a stoplight symbology as you look at this. And just to sort of see, keying in here, if you look at it, just taking an example, this one here. So again, the consumption value is sorted, and then looking at it and when it was tested, or what was the testing frequency that was set up for this particular meter, and then actually visiting the site. This meter is not testable. So the yellows actually start to move into their capital improvements plan. They're able to take this information and populate it. And then you can look at it and say, okay, by revenue, looking at the red one here, gosh, it was to be tested annually. It's been tested once. It has a value to us of $88,000. We probably need to take a look at that. So what this does is it starts to bucket out for them the highest priority meters of testing, really of their ongoing annual program. So in looking at the layout, when they go out in the field, they do the logging, you'll see that there's a composite average meter accuracy that is predicted, and then when they actually do the flow logging and the testing in the field, they're updating that model, actually updating revenue, which then in turn will set for them kind of an action statement. So if you see, there's what is the final composite accuracy? What was the revenue that's there? What's that potential revenue? What's the cost of action? And then boom, is there an action or not? Again, it's a cost-benefit analysis for the large meter testing. You can see there's replace, and then obviously the replace there'd be a retest, repair, or retest, and then it's part of the overall program. So their concept is, what is the payback for us to actually go through and do a lot of what we've heard throughout the course of the day? And each year, new data set comes in from the revenue that's actual revenue for that year. That sets up their large or their customer commercial meter testing on a large scale. The other side that I've heard a lot, and I'm excited about it because this is what we see every day, is get the results out to the leadership and do it in a visual fashion. How is this actually working in the field? And so that's actually plotting the annualized results of the revenue recovery that's there from their program. In some scale, this may be very small for this utility. This is a big deal because this is revenue that's being generated from their activities, which is pretty powerful. And then do that on a cumulative basis of looking at it since the program. So this is helping management, back to the thing we heard, to keep the gas coming. You know, when we're sitting here, we're looking at it and making sure we're putting those resources or keeping those resources on large meter testing, that there's proof in that. And this is also things for management to show the actual customers. How are we doing? Are we being as effective and efficient as we can? So, I think I'm trying to pull us back with energy and on time. So, I will say that I am excited, like I said, to be here in Bucharest, back in Romania, and the topics and things that we're talking about over these next 2 days, I can already tell based on day one, it's fantastic. I encourage you to make the trip across the pond and come to the North American Water Loss Conference. This is the 3rd conference solely dedicated to water loss in the States, and IWA has had a voice in this particular conference, and we're excited about it. It's also joined with Alliance for Water Efficiency, Water Sense, etc. But you're going to see case study after case study of utilities telling their story. And in the case of the states, in many cases, water is plentiful and it's cheap. So it's been an uphill push of that ball to get utilities to really embrace this, but it's happening. And there's some exciting things as state after state, and I'll talk a little bit about this tomorrow if you get to hear me in the morning, are really taking this step. I encourage you to put this on your calendar. It's in Country Music Hall of Fame world of Nashville, Tennessee, and